Hi, this is a recording on using logs to solve equations. So the first thing that I want us to do is just to think about what these two answers would be. So if we have log base 4 of 4, and we're trying to figure out what that will equal, um, let's write it in exponent form, and I think that will help you to see the answer a little bit better. So if we want to convert a logarithm to exponent form, this number is going to stay as the base. This number becomes, or in this case a letter, is our exponent, and then it equals the number that was inside of the logarithm. So if you think about this, it's saying 4 raised to what power equals 4? So x is going to equal 1, right? 4 to the first power equals 4. So if you notice, if I write this in logarithmic form, what we're saying is log base 4 of 4 equals 1. Okay, let's do a similar thing here. Log base 10 of 10 equals y. Let's try to figure out what y equals. If I write it in exponent form, it would be 10 to the y power equals 10. And this y goes there, this 10 is coming over here. So 10 raised to what power equals 10? Well, again, 10 to the first power is 10, so y equals 1. So if I rewrote this, it would say log base 10 of 10 equals 1. So if you look at these two examples, you can see a pattern. If the base and the number inside of the log are the same, the logarithm is 1. So if the base and the number are the same, the logarithm is 1. Okay, so we're going to use that idea on these problems. The directions say solve. Find each exact answer and use a calculator to approximate answers that involve logarithms to 4 decimal places. Well, if you look at these problems, none of them involve logarithms right now. But we're actually going to put logarithms in there. And the reason that we're going to do that is if I want to solve this first problem, this problem isn't one that's quite so easy. One technique that you can use is to get the base on the left-hand side, which is 4, and the base on this side, right now it's 100, but if I could somehow rewrite 100 as 4 raised to some power, I could solve the problem that way. But 4 squared, or 4 to the 10th power, or 4 to the 5th power, 4 to some power, doesn't exactly equal 100. So that's where we need to use logarithms to help us out. What we're going to do is we're going to say, okay, I want to figure out what this exponent is, so I'm going to get rid of this base. And to do that, you're going to just apply the log base 4 to that side. Remember that the power property says that this c can come out in front. So I can rewrite this as c times log base 4 of 4 equals 100. I'm trying to solve for c, but think about what we did on the last slide. What's going to happen to this? The base and the number inside of the log are the same, so that comes down to 1, reduces down to 1, or cancels out essentially, because c times 1 is just c. Oh, I forgot to do something very important. Whatever you do to one side of the equation, you have to do the same thing to the other side, right? Oh, and it's not going to let me just erase that. There we go. Okay, so I forgot to also apply log base 4 on the right. So we want to do log base 4 of 100 over there as well. So C equals log base 4 of 100. Now we're not quite done yet because we don't have a number for log base 4 of 100 yet. So we have to keep going. And you'll also have to remember the change of base formula to get this into a number that you can put into your calculator, because right now it's log base 4 and that will not go into our calculator. We want to write this as log, we could do log base 10, which is just log. If you don't write the 10, it's always implied that there is a 10 there. So if I just write log 100, that means log base 10 of 100. And the 100 is going to go in my numerator, and then log base 10 of 4 will go in my denominator. And now I can put that into my calculator. So there are a few steps to get there, but once you get the hang of it and do a few of these, it's not too bad. So the final answer is, and it does say to round to 4 decimal places, so 3219, 3.3219. All right, let's try this one. This one we can do, or you probably could do in your head. Well, not in your head, but you could probably get around it without using a logarithm. But we're going to do it using a logarithm just so you can see how it works. And I'm going to apply a log, again to the side that has the exponent. And I'm going to do a log base 10 because this number is a 10. So notice that's what I did above. Whatever your base is that you're trying to cancel out, you want the base of your log to match that. Okay, and then again, I would also want to do that over here. So let me write that out. Also, I'm going to bring this exponent out in front. So you'll find that that is pretty much always what you want to do if your logarithm has an exponent inside. So I have x times log base 10 of 10. And then on the right hand side, don't forget to apply log base 10 of 10 over there also. Okay, and then again, what should happen on the side where your exponent was is, and that's your goal, that's why you did it, so that should check out, is that'll cancel out to be 1. So I just get x equals, now on this side, I can just put this in my calculator. Be real careful, you probably want to put parentheses around that when you put it into your calculator, just so that it does, otherwise it will read it as log base 10 of 1 and all of that divided by 100, rather than the 1 divided by 100 inside of the log. So just put parentheses around that, and you can put that into your calculator. You can also put it in like this, log base 10 of 1 minus log base 10, which again, I don't need to write the 10 there. If I just write log, that's always implied there's a base 10. So I could just write that as log of 100. But because of the division up here, we can break that into 2 logarithms with a subtraction sign in between. So if you're more comfortable typing that into your calculator, you can do it that way as well. Either way, we should get the same answer, which is -2. And that makes sense. I forgot about that. This was one we could do in our head, but that makes sense because what you can do is you can write 100 as 10 squared, and then if you have something in the denominator that you want to bring up to the numerator, you just write that as with a negative exponent. So I could write that as 10 to the -2nd power, and so you can see my original problem on the left was 10 raised to what power equals 1 over 100. Well, 10 to the -2nd power is 1 over 100. So that's why it's telling me that my exponent should be -2. Okay, let's try this one. This one is more complicated. The last 2 problems you just had a single term on the left. Over here we have two terms on the left. So the first thing that you want to do is you want to get the term with the exponent by itself. So I want to take 13 away from both sides, and I would get 10 raised to the x power equals negative 3. And then proceed like I did on the last two. I'm going to do log on this side and then also over here. So I would bring the x down in front. X times log base 10 of 10 equals log base 10 of negative 3. And then again, log base 10 of 10 cancels out, becomes 1. I get x is equal to log base 10 of negative 3. So you can type that right into your calculator because your calculator does log base 10. So if you do log base 10 of negative 3, what happens? You get an error message. Well, the reason is that if you cannot take a logarithm of a negative number. And if you think about it, the reason is that you can't raise 10, you can't get a negative number out of raising 10 to some power. And that's what you're trying to do there. So that's why you're getting the error message. It just means that you can't do that. But if this was a positive 3, for example, you would get a decimal there. So that's still a good method. There's nothing wrong with the method. The reason that you're getting the error method is that you can't put a negative inside of a logarithm. Okay, let's talk about how to solve some of these using when you see this e in here. And again, e is just a constant. It's just a number, just like pi. When you first saw pi, that was very strange, but now you learn that that's 3.14, and e is the same type idea. It's 2.72 if you round it to the hundredth spot. And we're just going to use the same idea that we did on the last slide, except we want to remember that log base e is really natural log. So on this first problem, if I try to cancel out the e, which is my goal because I want to bring this exponent down, I want to get it out of the second story, I want to bring it down to the first level, first floor, and so I would do log base e, because again, to do that you want the base of your exponent and the base of your log to match. But really, that's just the same thing as natural log. So log base e and natural log are the same. And then I'm going to bring the 4x out front because that's always what you'll do if you have an exponent. And then we want to do natural log of 5 on the right hand side. So again, natural log of e will cancel out, will become 1, and I get 4x equals natural log of 5, and I want to go ahead and solve for x, so just divide by 4. And then you can put this into your calculator, and that'll tell you what that exponent should be. So natural log 5, and then if you have a parenthesis, close your parenthesis, and then divide by 4. Or you can do it in two separate steps, but just be careful there that you don't do natural log of 5/4. Just be careful where you place your parentheses. And you should get 0.4024. Okay, let's try this one. Now in this one, again, like on the previous slide, you want to make sure that you just have your base raised to the exponent. So the 3 actually is not raised to this 2x minus 2 power. It's just the e. If it was the 3 as well, you would actually have parentheses around there like that, and we don't. So we're not going to let me erase that. We're not going to think of the 3 is raised to the 2x minus 2 power, so that means that we need to get rid of it. And so we would just divide by 3 because right now it's being multiplied by that e raised to the 2x minus 2 power, so just divide to get rid of it. Cross those out. You have e to the 2x minus 2 equals 4. 12 divided by 3 is 4. And now you can go ahead and apply the natural log to both sides. And then I will also bring that 2x minus 2 out front. So you have 2x minus 2 times the natural log of e equals the natural log of 4. And that just cancels out and becomes 1. So I get 2x minus 2 equals the natural log of 4. And you can put that in your calculator. Or you can wait till the end, either way. 3863. And then just keep going, solve for x. So now it's, just regular algebra, add 2. So you get 2x equals 3.3863. And then divide by 2. $1.6931. So I hope that helps. Let me know if you have any questions.